For over a decade, a massive alien planet was secretly photobombing our images of deep space, and the world's greatest astronomers missed it. The star is Beta Pictoris. At only 23 million years old, it's a nearby laboratory for studying how planetary systems form, making it one of the most intensely scrutinized targets in the Milky Way. But discovery here is difficult because of a physical barrier. Beta Pictoris is surrounded by a massive debris disk that we see edge on. This thick band of dust intercepts the star's light and scatters it, creating a blinding cosmic fog. Trying to spot a planet inside this disk is a massive contrast problem. It's like finding a firefly next to a lighthouse. Traditional imaging had reached its limit. To see what was actually hiding in the disk, astronomers had to stop looking for light and start looking for chemistry. This massive breakthrough happened entirely by accident. The James Webb Space Telescope wasn't actually looking for a new world. It was aimed at a different, already known planet to study its atmosphere. Webb used its NIRSpec integral field unit. Instead of a flat picture, it captures a three-dimensional spectral wave for every pixel. This allows astronomers to mathematically filter out the cosmic dust's scattered light and isolate narrow molecular signatures that are otherwise invisible. In a patch of the disk that appeared empty, a distinct barcode emerged, the chemical signatures of methane, water vapor, and carbon monoxide. This combination of molecules doesn't belong to cosmic dust. It was the undeniable fingerprint of a hidden gas giant, Beta Pictoris d, weighing more than twice the mass of Jupiter. Once Webb provided the chemical proof, astronomers finally knew where to look in their historical records. At the Very Large Telescope in Chile, an independent team began digging through 11 years of archival images to see if they could find the planet they had previously missed. They found it. By mapping these data points from the archives, they successfully tracked the planet's movement over a decade, proving it was bound to the star in a massive 91-year orbit. It remained hidden so long because it's 100 times fainter than its sibling planet. Buried in the glare, it is the faintest exoplanet ever imaged from the ground. The planet hadn't just appeared. Because we were relying on traditional visual imaging, it had been secretly photobombing our most advanced telescopes for years. Accounting for the presence of Planet D provided a potential explanation for a long-standing mystery involving the system's architecture. Researchers couldn't explain the inner dusk disk's sharply defined edge or its strange 5-degree tilt. Planet D sits in the precise orbit to act as a gravitational snowplow. Its mass sweeps the area clear, carving that sharp inner edge and forcing the tilted alignment. This discovery marks the first time a directly imaged exoplanet was identified primarily through its chemical fingerprint rather than the light it reflects. If a world twice the size of Jupiter could hide in our most studied data for 11 years, it raises a profound question. How many other planets are currently sitting in our archives, just waiting for us to read their barcodes?